All right, so today is 11:04, but we're going to finish this really quick. So, who can refresh my memory, since I wasn't here yesterday, who can explain to me what the process for solving two-step equations is?
Aren't you our math teacher?
But I wasn't here. I don't know. I wasn't here for the lesson. You got to tell me what to do. Baylor?
Okay, so you have to take the constant, which is on the, normally how I see it, it's on the left.
It's just normally how we set it up.
Yeah, so you have to take the constant on the equation, and then you have to subtract it from both sides. So there's no more constant on the equation side, and on the other side there's just, it's the, well, if it's plus, you have to do the inverse operation of what, you have to do the opposite operation of what it is. So if it's plus 12.75, then you have to subtract 12.75 from both sides.
You're going into a lot of detail. I like what you're doing, but you're doing a lot of detail. We got to hurry today. So everything Jackson says right. It's this. This table from the front of yesterday's notes, what we're finishing up today, is vitally important. Today, where we're going to switch this a little bit is that first, above this, is going to be simplified. So if you want, I would flip to the front real quick and right above that really, like, step 0, like the before step 1, is to simplify. Because that's not part of solving. That's just part of rewriting the equation. What's up? Whoever passed out notes yesterday, did you put it in here?
No.
Was there no extras?
Yeah.
There were no extras?
No.
How dare they?
Yeah, I'm putting in my 15-year notice for Shelton. My 15-year.
Oh, I don't know why I'm short one.
Give me your 15-year.
I am just going to have to print you one. So will you run to the black and white printer and grab this? All right, so you should be able to highlight, underline, circle, star, whatever you do to notify yourself of what's important in here. And then you should be able to set up the equation. Now, here's the thing. Most students in my 3 years of teaching so far, well, 4 years now, mess up this problem because they're not paying careful attention. You want to solve how many total hours you had this boat. I challenge you to carefully solve this and tell me how many total hours we kept this boat. I'm going to give you probably like a minute, minute and a half. Think about what is constant, what only happens one time, what don't we know. For each additional hour. So guys, when I was DJing, to set this up as like a different perspective, when I would DJ, I would charge a larger amount for the first hour because I had to drive there. I had to set up. I had to like change my schedule to make this happen. But then every hour after that, you're only paying for like my services, for me just playing music. So like I would charge maybe, this is not what I would charge, but just for example, you might charge $200 the first hour and then $100 every hour after that. I was much cheaper than that, but just for an example. So here the boat rental place charges $60 for the first hour and then $20 for every hour after that. Question or answer? Answer. Take another like 30 seconds, see if you've looked at everything in the problem. And you didn't really, you want to write out the equation and everything to be able to do that because as we get harder and harder, we're going to need to write the equation. But that's a good process. I see what you did. Trap door. Who can tell me the equation? Actually, I need to use cards because you guys are already like jumping out of seats.
Me, isn't it?
James.
Yes.
Did you set up an equation here?
Yes.
What do you have?
20h plus 60 equals 140.
I love that you wrote the variable term first. Now, as you read this, you probably thought in your head 60 for the first hour plus $20 for every hour after that. James, why did you choose to write the variable first?
Because I'm used to that.
Because we like it better. It's just nicer for my brain because then I can say, oh, the H has addition happening to it and it has multiplication happening to it. When we write it like this, sometimes your brain gets a little goofed up since it looks like plus 20, but really that 20 is multiplying, the 60 is adding. So then, Peyton, what would we do next?
Subtract 60 from both sides.
We would subtract 60 from both sides, get rid of that first hour charge. So then my additional hours, 20 hours, equals 80. Olivia, what would I do here?
You would divide 80 by 20.
Well, really, we do it on both sides. And that gives me H is equal to 4. But that's not your answer. Leah, why is 4?
You still have the first hour.
The first hour, this 60 already happened. These are the additional hours. So we have 4 hours plus the first hour really makes a total, well, not H, but I'll say T for total, of 5 hours. Your total time. This is what I was saying. Most people don't pay attention to that first hour happening. You just solve the equation like, H equals 4. Well, okay, that's what the variable equals, but that's not what the question's asking. Question's asking how many total hours. Questions, comments, concerns? Who thought through and actually had 5 there? Yeah, I know Leah did because she showed it to me. Yeah, only a few of you guys. So you got to really pay attention, especially on those standardized tests. Why we practice problems like this is a real world. You got to think through all these things. Like when we were in Maine, we rented kayaks because we were on this huge lake. Lake Erie's obviously the biggest lake I've ever seen. We're on this huge lake. Wanted to rent kayaks, but if you take it back after the first hour, somebody else might take it, and then you can't get it back. So this might be why they kept it for all 5 hours, because maybe they had the boats and then went to lunch and whatever else. So it's just, you got to think about those realistic situations. Now, when we look at today's lesson, the first thing that we deal with is our bagel baker. Our bagel baker has decided that he is not charging enough money. So he decides each bagel is going to have a price increase of 5 cents. Delicious.
They're healthy donuts.
So what we have to think about is how do we represent that every bagel is going up in price? How do we represent that every bagel goes up in price? So how, yesterday or in the previous lessons, how have we expressed a dozen bagels when we don't know the cost of a bagel? Olivia?
12x.
Yeah, 12x or 12b or something. I like to use b because it's for bagels, and we just use x all the time, so whenever I get a chance to not, I take that chance. So we say he's going to increase the price by 5 cents, right? So we can just write, okay, increase the price by 5 cents.
No,
Noah?
that's not right.
I was waiting.
No. Yeah, why don't you just write 5 cents instead of the 0.05?
Because we're in dollar form. But still, this isn't right. Pranav?
12 is the number of bagels.
You're right.
So we need to find the price of those bagels before we can
No, we don't.
We can't add, we have to multiply. We have to
No, we
add,
don't.
right? We have to multiply by 5.
Zach? No, there's only 12 in a dozen. We were talking about a baker's dozen the other day. But an actual dozen is 12. Karen? Well, no, but it could be 5 times something, but it wouldn't be B. Remember, B is the price of one
Would
bagel.
it be 12?
You got beat out by Ella. Do you know?
Yeah, I was gonna say
this, how it's written, only adds 5 cents to the entire price, not to every bagel. Here's how we fix it. That now adds 5 cents to my bagel price before I buy the dozen, because parentheses has to happen first. So when I write it as 12 parentheses B plus 0.05, now I've added 5 cents to the individual bagel price, then I multiply by 12. So because you said, would we multiply it by 12? We do, because when we distribute, we now get the 12 times the B and 12 times the 0.05. So it would actually be an increase to the dozen price of how much? 60 cents, right? My dozen bagels will be 60 cents more than they used to be. If each bagel is 5 cents more, the dozen will be 60 cents more than before. Questions on this? Does what we're doing make sense? That we have to add it to the individual before the multiplication happens.
So you use distributive.
So we have, notice, well, our learning target's gone now, but our learning target was solving equations using the distributive property. And then the process is we distribute first, then. So that, the step that I made you guys write above, that simplify step, that's going to be the distribution. That's what we have to do first. Let's try this. So we want to remind ourselves how to distribute. And remember, there's always options in math, which makes it a little challenging because you have to choose. When we see, and on your notes it's not filled in, so you need to fill it in. When we see addition between the terms and we distribute, draw the arrows. A times B plus A times C. Again, draw the arrows. Now it's A times B minus A times C. Now the options that I was talking about, you can either look at this minus as being a minus, or you can look at it as being a negative, but it can only be one of them. It cannot be a minus and a negative. It can only have like one existence. So here we just said, oh, it's a minus. Let's take it as a minus. So when we look at solving these two equations down here below, the first thing we're going to have to do is simplify, and that's not part of solving, it's just part of rewriting. Because can I do x plus 3/10? Can I do that addition? No, why not? Seth? They're not like terms. So remember, we have to have like terms before we're allowed to actually do things, but I can do some other stuff with non-like terms. I can multiply or divide with non-like terms, and that is perfectly okay. So first thing here, draw the arrows. -8 to the x, -8 to the 3/10. I'm going to bump over so I have a little bit more room. So that gives me -8 times x plus between them, -8, I'm going to put that in parentheses just because it's a negative, times 3/10. That's going to equal my 3.6. Now, I wrote the whole thing out, but obviously, can we do this multiplication? Yeah, they're two constant terms. We have -8 and 3/10. Now, do not touch a calculator. What's 8 times 3?
24.
24, so just bump your decimal back one place. It's 2.4. That's how you make the math easier. Do what you know how to do, and then move the decimal place. So now we have -8 plus -2.4 equals my 3.6. Notice that I haven't changed colors yet. I've not done any solving. I've not done anything to both sides. All I've done is simplify so far. Reminder, colored pencils up front if you want them. I think colors are extremely beneficial to helping your brain pay attention to things. You are welcome at any point in class to come up and get colored pencils if you decide you want them. So now, there's one last thing I would like to do to just tidy this up. Make it look a little better. Make it a little easier to look. Karen.
Negative 8x minus 2.4.
Yeah, instead of saying negative 8x plus a negative, I can instead change this to just minus 2.4. Instead of writing plus a negative, I can just write it as minus. So now it's easier to see what we need to do. So Grace, now that I've rewritten it like this, what's the first thing I should do? Add 2.4 to both sides. Guys, right here is where we're starting solving. Up until this point, nothing we did had to do with solving. It was just simplifying. My left side is now going to be negative 8x. My right side, don't touch a calculator. These numbers work nicely together, Shahib. Yeah, it's just 6. Because the 4 and the 6 make a whole, we carry it up, and then we get 6. Then to finish us out, Ashton, what's the last thing we do here?
You divide 6 on each side. Or you divide both of them. I don't even know what I just said. Okay, so you divide 6 by 3.
You're very, very close. 6 by
Negative 8.
negative 8. So remember, you're always dividing by the entire coefficient, or the number that multiplies your variable. A coefficient is the number that multiplies by your variable. We can write it in fraction form, or we can write it in decimal form. Either way, they are the same. Now, how would I check this? If I want to verify, is my answer right? I don't want to ask digits, is my answer right? I want to check, is my answer right? Karen? Take your x, plug it in, and do the math. Now that you have a value for x, and this will, in fact, come out to be the right answer. Coolio? He's a rapper. From like 20 years ago. All right, try the got it on your own. Now, here, you have the option, I'll get you in a second, you have the option to not distribute. I would like you to distribute, to still practice doing it with the distribution. So I'd like you to distribute first, then solve it by using the process from yesterday. Question?
How to get the negative 8x to equal 6?
So when I added 2.4 here, it got rid of that. And then when I added 2.4 over here, it equaled 6, and then I just dropped it down. Good question. Because any time it's just not clicking, please ask the question. I hope at this point in the year you're comfortable enough that you realize there's no dumb questions. There's no bad questions. It's all what's relative to your brain. Just ask it. If it's not clicking, a quick question can really help. First thing you can do at least is draw the arrows. You're trying to think through the whole process before you... What do you mean? The process or the... I mean, this is not relative to a real problem. It's just practicing the math. The real problems we get to on the back of the page. This is just practicing the math skills. I got a ton. I've been making so many copies. Every time I make a copy, one of these comes for every single different set of copies I make. So when I make like 7 sets of notes, I get 7 of these stupid blank pages. That's a waste of paper. So yeah, use my scrap paper. I got these notebooks too from Mrs. Goldering's husband. He works for the Ohio High School Athletic Association. So if you want like a notebook of scratch paper, there's a few more of those up there. There are no trapdoors here. You really shouldn't need a calculator because if you have 3/4, you know that means you get 3 out of every 4. So Shahid, what's the first thing you did, or do you have a question or an answer?
So I part of the answer.
Part of the answer. So I got to work through the process, right? So first thing we do, first thing we draw.
I did 3/4 times 8.
And I'm going to draw the arrows, which we should to help us remember all the multiplication that we have to do. So I have 3/4 times 8b. Yeah, which is going to give me 6b. I carry down the subtraction. So I say, okay, so this is going to be minus. Now that I used it as subtraction, this 4 I can think of as being positive. Hey, Seth, you signing in or out? Can you wait till Rye gets back?
Yeah.
We're trying to keep only one of you guys gone at a time. Then the 3/4 gets multiplied by my 4, which is real easy when you look at what can cross cancel. It's just 3. And the right side didn't change. Notice I've not changed colors. I'm not solving it. All I've done is simplify. Questions up to this point on just the simplification, the distribution, and then just doing the math? Questions? Okay, so now, Jackson, what's the first thing I want to do in my solution process?
Okay, so when you're trying to find the solution, you have to subtract. No, you have to add the constant. Damn, I messed up on this. You have to add the constant. So that would be adding 3. So if you add 3 to -2, it's positive 1.
Yep, so now 6b equals positive 1. I'm out of space, so I'm going to come over here.
It's pretty simple. And for the last step, because if you just write the equation out, it gives you the answer. It's 1/6.
Yeah. If you think of it in fraction form, well, if I'm going to equal 1, this has to be the reciprocal, because 6 over 1, its reciprocal is 1 over 6. Or we can do the division on both sides. Now, you can leave this in fraction form, and this is one where I would prefer that you leave it in fraction form. But if I put it in decimal form, what's cool about 1/6 in decimal form? Shahib?
16, but the 6 is
Yeah, really, I like to say 1/6 is 0.16, but the 6 repeats. And there's no, like, that doesn't always happen. It's just cool that 1/6 does that.
It doesn't equal -2
You have done something wrong then.
though.
So you would have to do, when you plug this in, are you using the decimal or the fraction?
I'm using the fraction.
Okay, so when you plug it in, 8 would have to multiply by the 1/6 first, then you'd have to subtract the 4, then you'd have to multiply by 3/4. You've got to do the order of operations correctly. So this multiplication in the parentheses happens, then the subtraction in the parentheses, then we get outside the parentheses to do the other multiplication, and it will equal -2. Not, come on. I don't want to. Any questions? No.
I'm not sure what I did wrong here. Can I ask you for class maybe?
Yeah, I'll check it out real quick. So this is just kind of like, hey, you should look at the problem before you try to solve the problem. So with this set, and we're going to write them down on your paper because you can't drag tiles on your paper, we're going to look at how many operations does it take to get the variable by itself. So here, you want to think about what do I have to do to get the, oh, you can't add first, you have to distribute first. Yeah, there's your issue. What does it take to get to just M? So Nate, when you think about how do I get to just M, what would you do there?
I would subtract 12 for both numbers.
And then do you have to do anything else?
No, so
No.
that'd be 1.
One operation, you just subtract 12 from both sides. Pranav, what about here? We have A divided by 2 equals 10.
Would I multiply by 2?
Yeah, you just multiply by 2 on both sides, and again, then your A would be by itself. You'd be done. Now, Shahid, what about this one? What would be your process? What would you do first? Next?
You would have to multiply the 7 by
So more specifically, what do we call that multiplication? We'd have to distribute, then,
We'd have to add, then divide.
Yeah, so we'd have to distribute, add, then divide. So we need more than 2 operations. Specifically, we can do it in 3. Now this one looks complicated, just because the fractions. But Lily, what would be your process for solving this here?
So you would add a half.
Yeah, you'd add the half to both sides.
And then you would just divide by 3.
Yeah, so we would add, then we'd divide.
So that would be
2 operations. You want to try one, Ella?
Well, I can kind of just do that as looking at it.
Yeah.
I think it needs more than just 2.
How do you know that so quickly?
Because it has the parentheses.
Yeah.
Distributive.
Yeah, so you know, when Ella saw the number against the parentheses, she knows, oh, we have to distribute, which is kind of annoying. It's going to take longer. It takes more than 2 steps. And this one, Mr. Bailey.
2 steps.
2 steps.
Because you would subtract the 13.9 from each side. So
Uh-huh.
you divide both sides.
Very good. Questions on this?
Can I just say something?
Yeah.
But you could also kind of just look at the other 2 because usually when it's only has 1, it has one number.
Yep. You can look at how much is being done to the variable. Here there's only one thing done to it, addition. Here there's only one thing done to it, division. Here there's multiplication and subtraction, multiplication and addition. Here there's multiplication and subtraction and another multiplication. 3 things being done, gonna take 3 steps. Very good, guys. So on the back here, we want to list the order. I know it says which are going to require 2 or more, but I don't care what they're asking. I want to know what process are we going to take to solve these. So remember, this was a prize problem 2 days ago. What do we do when we have a fraction in front of it? This is not a prize problem today. I'm just trying to get you to remember it by it being a prize problem a couple days ago. So, James, we haven't really talked much today.
You multiply by the reciprocal.
Multiply by the reciprocal. And then would there be anything left to do? Yep, that is absolutely right. So the only B, I did that the other day on notes too. Multiply by reciprocal. So that would only take 1 step. That would be the only thing that you did. Now my next one here, Mr. Silliman.
Well, that one takes 2 and 1 because it has the
Well, okay, so let's talk in order. What would you do first?
distribute.
Yeah, so my first step here would be to distribute. And if you want to abbreviate, you can. You could do DIST. My next step after I distribute, now be careful, think it through. After we would do the distribution,
Add, right?
No.
No.
Wouldn't you subtract? Because -5 times -1 would
that's why I said be careful. The -5 and the -1 would actually make a +5. Because remember, they're multiplying. So since that would turn into a positive, we would then subtract. And then the last thing we would do is divide. And my last one here, my first step. Nate?
multiply?
Ooh, can never do that first. Unless there's only division happening. But we see multiple things going on.
Subtract.
What is happening? What is happening right here? So we want to,
Inverse, so add.
yeah, we want to inverse. So we want to add, specifically we would add 19 if you care to be specific. And then, careful. Ella?
Divide?
Ooh. Remember, the fraction is what goofs us up.
Oh.
The fraction is what messes us up. Peyton?
Multiply by the reciprocal.
Multiply by the reciprocal. And you can abbreviate that if you want. Mult by recip. Will help us remember that. Sheeb?
When Ella said divide, couldn't that also sort of write?
Yes, but we don't want to do that because dividing by a fraction is really messy. It really, like, dividing by a fraction is, yes, you can do it, but it doesn't make sense. like when you think through the math as a practical application, it doesn't make sense to say I'm going to divide that by half. Because really you're multiplying by 2, and saying divided by half doesn't really, like I can divide something by 2, which cuts it in half, but dividing by half, that's like saying if I have a pizza and I'm going to give it to half a person, how much pizza does that whole person get? Well, they would get 2, because if half a person had, it like doesn't really make sense.
Can you say like a divide into a half?
But it still doesn't make sense. Like,
But that would
so if you said like I have 4 marbles in half a bag, how many marbles are in the whole bag? Like 8. But that doesn't like, that's a weird way to approach it. If you say 4 divided by a half, you know, that's why we just multiply by reciprocals. Zach?
When you do multiply by the reciprocal, would you multiply the 17 by 5?
It wouldn't be 17 anymore.
Yeah, but when you multiply the n number by 5,
So we would add 19. I need to change colors like I normally do. So we'd have 3/5 x equals 36. I think when you add those 20, yeah. So then we multiply by the reciprocal. It'd be 5/3 over here, 5/3 over here. We can cross reduce. My 36 and my 3 share a 3, so that becomes 12. That becomes 1. 12 times 5. This will give me that x is equal to 60. So if you want the solution process for that guy, it's in the notes now. Cool? Jackson?
I have a question.
Yeah.
Well, it's more like a comment. When we solve your way of solving these math problems, I'm just now looking at it. All we do is take the equation and then whatever, like with the 19 and the 17, flip change the operation and then
move it.
over.
Yeah.
And
Did-
stay the same.
So I asked the guest teacher to talk about it like this. These two values are both constant terms. All we're really doing in this step is combining the like terms. We're moving the constant value, because what I say is this I want to be the variable side, and this I want to be the constant side. So get the constant over on the constant side. How do we do that? Inverse operations. Awesome. We got to move on. We might get through this lesson, which would be wunderbar. All right, family of 6. Anyone have a family of 6? You got 4. So, well, you have more than 6, don't you? Okay, so that would cost a lot to travel. How is your sister, by the way?
she's good.
She good?
Spitting up a lot.
Oh, well, babies do that sometimes. She ruined any of your shirts yet? Yeah. All right, so a family of 6 buys airline tickets online. One of the issues of purchasing things online is a lot of times there's going to be a fee for the fact that you did it online, it was convenient, it was easy. So this family of 6 buys airline tickets, but each ticket has travel insurance that costs $19 per ticket. So whereas yesterday you did situations where something only happened once, the fee happened once, or the first hour of the boat happened once, that $19 happens to every ticket. Kind of like the baker increasing each bagel. And then we know they spent a total of $1,116. So in your no box, K-N-O-W, not N-O, we know there's 6 tickets and insurance, which I'm going to abbreviate by INS, and that'll equal my total. Now we know that the insurance is $19. And we know that the total is $1,116. So we can replace with what we know, but the problem is this tickets plus insurance has to be together. And this ticket is the price of each ticket. So when we write this numerically, we're going to write 6 times the quantity. When you use a parentheses, if you're trying to say parentheses in math, you say quantity because it's grouping. So 6 times the quantity. I'm going to just say A for airline ticket. You could say C for cost or something like that. plus my $19 for insurance for each ticket equals the $1,116. Use a comma so it breaks up your place values. Sheep?
I remembered, I just remembered this right now.
Yeah?
My brother said you should avoid using the variable t.
Yeah.
It can look like a pencil.
Yeah. If I haven't said that in here, yeah. Avoid O, avoid T, avoid lowercase l unless you write cursive. You need something, Tony?
Rumor has it you have AAA batteries?
No, rumor has it I need AAA batteries, like really badly. So if we could place an order, that'd be great.
Okay.
Yeah, yesterday she kept
See, rumors can get totally skewed. I was asking teachers, does anyone have AAAs? Somehow it got turned into I have AAAs, which is not true. I need them for my calculators, not the simple ones, but the ones for my high school class. Yeah.
Can I solve it?
Yeah, sure. What do I do?
Distribute
Distribute
the 6.
the 6.
And 102.
1002. I'm going to come over here because I'm running out of space. 6a equals 1002. Zach just said then we divide by 6 because this 1002 is now the total cost of just the ticket. So all 6 tickets cost $1,002. So we divide by 6, we're really finding what? When you're finding the price of one thing, what's that called? Unit price. So my unit price for these tickets, which is actually really cheap for a plane ticket, $167.
That's very cheap.
That's extremely
Back when there was like Airbus or those really cheap airlines, you'd be able to find tickets for cheaper than that, but they went out of business because they had a bad business model. They were not filling up their planes, they were losing money. So that's why airline tickets are expensive. If the plane's not full, they're still flying the route, so they jack up their prices. So in case the plane's not full, they can still make all their money.
6 people, that's...
Yeah, that's not bad. So who's seen Home Alone? So imagine, even back in the 90s, when Home Alone was made, even back in the 90s, if you were to travel to France with your entire family, that big of a like, yeah, your cousins, your nieces, nephews, uncles, aunts, it's really expensive.
That was kind of unrealistic.
Well, actually, I think the setup is like he makes a lot of, like the dad makes a bunch of money.
That's like
I
really
mean,
rich.
yeah, their house is extravagant.
Yeah.
That house was for sale again, by the way. Every time it's for sale, it makes like national news because like the Home Alone house is for sale, but it's like $1 million or something like that. Try this on your own. You are gonna mail 20 identical invitations weighing more than an ounce. You know that for the first ounce of postage, it's 44 cents. This is also old math. Postage prices have gone up. Plus 17 cents for every additional ounce. Total postage cost is $15.60. Write and solve the equation to find the weight of each invitation. So a good thing to look at is what is my variable? My variable is the weight of each invite. So think about how do I set this up? I know how many invitations. I don't know the weight. I know what the first ounce costs. I know what every additional ounce costs. So if I want to look at the weight of each invitation, it'd be like W or something like that. How can I set this up? This is tough, right? It doesn't jump out at you like, hey, here's something fixed and here's some change. 20 invites. They all weigh more than an ounce. Are they all going to weigh the same thing? Yeah, wouldn't you expect that if they're all the same invitation, they would all weigh the same thing?
Yeah.
So we know they're all identical. That's what that's telling us. They're all weighing the same thing. This is why I start by writing out the verbal expression. I have to mail 20 invites, and that's going to multiply by the price of each, or the price, like the postage price. I'm gonna write that. Equals my total.
Bayla, you lost your vocabulary book again.
Zach?
I think it would be 20 and then W plus 0.17 in parentheses.
W plus 0.17. So we know that they're all more than an ounce. This is like the boat problem. Yeah, so I talked with you a lot today. Peyton?
I'm just guessing, but so inside the parentheses, 0.17 and then
Sure.
plus 0.34.
So what we really want, and we will, so get this written down before you take off. 0.17 is the weight over 1 ounce cost. So this W is actually going to solve for the weight over the first ounce. Then we have to add the first ounce, and that will equal 1560.
Wouldn't that be inside the parentheses though, because the point over, because then it would be multiplied by the 20 and you only
It's got to be multiplied by the 20. Because think about it like this: like if your invite weighs 4 ounces, that breaks down into the first 1 ounce and the additional 3 ounces. So the first ounce is 44 cents. Then it would be 3 times the 17 cents. So really, the weight of each invite, we're going to have to break it up. We're going to find the additional weight and then add that original ounce.
but you only have one first ounce.
For every card. Because each one has to pay that postage. So good question. We're going to finish this tomorrow. But I like how you were analyzing it.
I turned in my math sheet.
Oh, I have stuff to give back to you guys.